Yeah, hi all. I'm here to give my project overview. So basically, this is my project, task 1, chat with PDF using RAG pipeline. So the main goal is to implement a retrieval augmented generation pipeline that allows users to interact with semi-structured data. So here, semi-structured data means, for example, data which is structured, but some of the data is in text format, or some of the data is in tabular format, or let's say graphs. So all this data is known as semi-structured data in multiple PDF files. Okay. So what my task is that I have to build a system that should extract, chunk, embed, and store the data for efficient retrieval. It will answer user queries and perform comparisons accurately, leveraging the selected LLM model for generating responses. So basically, this is my overview of the task, and let me do a detailed code breakdown. So I have created the program in Google Colab. So as you can see, this is a program which I have developed. So these are all the libraries which we are using. So all of these are libraries: import PDF plumber and import files, import fairs, numpy. All these are libraries. So these libraries, they help us with PDF processing, text analysis, and AI powered question answering. So that's the reason we use this modules, or let's say libraries. They are used to extract text and tables from PDF files. So let us start discussing what PDF plumber does. So basically, PDF plumber is used to extract text and tables from PDF files. So by using this module, we can extract text and tables from the PDF file. So it will recognize what are the text and tables in the PDF which we upload here. And to upload the PDF, we are using Google.Colab, which helps us in uploading files like PDFs directly into the Google Colab. Next is sentence transformers. So basically, sentence transformers means this is a model. For example, a model which is used to convert text into embeddings. Embeddings are nothing but numerical representations of the text. So it is a way of text processing. So whatever the text is there in the PDF, it converts them into embeddings. Embeddings are nothing but numerical representations of the text. Embeddings. For example, CAT is nothing but C1, C2, C3, or let's say 1, 2, 3, like that, into numerical representations. So FAS means nothing but it is a library for efficient similarity search. It is basically a library which is used to find the most similar chunks of the user query. By using FAS, we can find the similar chunks of user query, whatever the user query is, similar to that there are few search results, right? So what it does is it will make a chunk of all those search results and then use them for efficient retrieval of data. That is done. And next, NumPy is used for managing arrays, and especially it is required for FAS. And next is these are a few transformers: auto tokenizer and auto model for sequence to sequence LM. And these are the functions. So these are all the modules which we are importing in this, and these are the functions which we will talk about now. So the first step is we need to upload a PDF to the program. So how are we going to do that? We're going to do that by files.upload. So what files.upload does is it gives the user a dialog box, or let's say this is a Colab interface. In that it will give us a dialog box which helps us to upload the PDF. And next, PDF path. What it does is after uploading, what this PDF dot hyphen path does is it retrieves the path of the first file, so which should be the PDF. So it checks that if it's the PDF, and it's stores it in a variable format. So for that we use PDF path. Okay. And next, with PDF plumber dot open. So next we need to count. So as for the third step, we need to open the PDF and count the pages. Like we need to know that if the PDF we have given, it has a right name, and it has the the length we need to it also tells us the length of the PDF. So for that we use this PDF plumber.open path as PDF. So it opens the uploaded PDF for processing. So here starts the processing part in this pdf.plumber open PDF path. So here the processing starts, and then the next step, total pages is equal to length of the pdf.pages. So basically what it does is it calculates the total number of pages that are in the PDF. As for the next step, it has to read all the text that is in the PDF and all the text that is in the tabular format, which is pdf.pages. These are all used for processing and retrieval of data. We have to give it a function to extract text and tables. So we use all text is equal to and all tables is equal to. We use all this to extract text and tables. And as for the next step, we use the model sentence transformer. This is actually a BERT model which we are using here. We'll break down BERT model later, but as for now we need to load the sentence transformer model. So by using this, we load all the sentence transformer. By using this sentence, we load the sentence transformer, and then it starts to extract all the PDF content slowly. And what this does is, next this is the extraction part. It extracts all the PDF, all the content from the PDF, this function. And if there is no content in the PDF, it will print this: no text or tables available to process. If the PDF we upload has no data or text in it and has only images in it, then we will get this output, which is no text or tables available to process. So after that, it starts to as it starts to read all the content from the PDF, and then it gives the embeddings. All the embeddings, these are embeddings is equal to model.encode. All the embeddings are made into chunks, and then all the embeddings are processed here. So after all the embedding is done, it generates all the embeddings for the text chunks. After that, all this embeddings or the chunks of data is stored in an index format, which is FAS index, so that we can easily access the data from the FAS index. As for the next step, we have next function, which is we need to search. We need a function to search the relevant chunks of the data. So for that, we use this search relevant chunks query, and by using this, we search the relevant chunks. And after that, we need a user query. Like, we need a place where we need to ask the user what he wants to find in the PDF. So basically, by using this user query function, please enter your query here. So this is the input. The user will see this, and we start retrieving all the relevant chunks based on the user query here. And after that, it calls the by using this function, we call all the relevant chunks of data which are relevant to the user query. So moving to the next step, we need to load the LLM model now. As far as here we can see, we are loading the LLM model here, which is actually a pre-trained model. And after loading that model, it starts tokenizing the input text, the user query, or as it is a pre-trained model, it tokenizes all the input text and loads the language model itself. And it has a try and except block, where here it has a try and except block which ensures error handling if the loading fails. If it fails to load, it will again try, and as an exception, it will throw this out: error loading the module, if the module doesn't load properly. And the next is we need to generate the answer from the retrieved chunks of data. So here, retrieved chunks of data and the query are brought together for giving to the user for generating the output. And for the final response, we are using. So if the relevant chunks are found, or let's say as per the user request, if the relevant chunks are found, then it generates an answer using this generate answer from the retrieved chunks. So it gives the output based on the user query, and if it gathers enough retrieved chunks, enough what do you say, related chunks, it just delivers them. And after that, if no chunks are retrieved in the end, if there are no retrieved chunks, it just gives this output, which is no answer generated due to lack of relevant chunks. So if the user request or the query has no relevant chunks, as I'm running the program right now, it has generated a dialog box for me. Now I need to choose files from my computer. I'm going to choose this PDF. I'm going to open it. It will first upload the PDF into the Google Colab and then starts working on the PDF. Okay, as we can see here, the number of pages in the PDF are 19. It has generated this, and it has generated the name of the PDF, which is tables, charts and graphs with examples from history, economics, education, and it has few. This is the name and this is the 17 to 18 PDF. So this is the name of the PDF and this is the total number of pages in the PDF which we asked it to generate. So embedding successfully stored in FAS index. So all the chunks which are retrieved from this PDF are neatly stored in this FAS index. And now it is asking for the user query. Now I'm going to give it user query will be psychology. So these are the relevant chunks found. Psychology is found in tables, charts and graphs with examples from the history, economics, education. This from this. So generated answer is psychology. So basically this is my project. Thank you all.